In this video, I would like to show you how to write orbital filling diagrams. This assumes that you already know how to write the electron configurations. So we're going to start at the beginning with hydrogen. And if I have hydrogen, I know it has one electron, and its electron configuration is 1s1. To do the orbital filling diagram, we draw a horizontal line representing the s orbital, and we write 1s underneath it, and you show the one electron in that orbital as an arrow, and that represents the one electron in hydrogen. So this is hydrogen's orbital filling diagram. Sometimes you'll see them written as boxes instead of horizontal lines, and they depict the same thing. Moving on to helium, helium has 2 electrons, and its electron configuration is 1s2. When you draw helium's orbital filling, you show both of the electrons in the orbital. You put one of them pointing up and one of them pointing down. That represents that they have opposite spins. So that represents the Pauli exclusion principle, showing that no 2 electrons in this same orbital can have identical spins. So if you tried to write the orbital filling like this, that would be incorrect because it violates the Pauli exclusion principle. Moving on, if we go to boron, boron has 5 electrons, and I'm skipping down a little bit. I'm not going completely in order. So boron's electron configuration is 1s2, 2s2, 2p1. When you write the orbital filling for boron, you'll write 1s, you'll show the 2 electrons, 2s, show the 2 electrons. For 2p, there's 3 different orbitals, 3 orientations of p orbitals. So you put the first electron in the first orbital. Now, let's move on to nitrogen. And nitrogen has 7 electrons, and its configuration is 1s2, 2s2, 2p3. When you show the orbital filling, you put the 2 electrons in the 1s, the 2 electrons in the 2s, and then the 2p electrons, you fill them up one by one. So Hund's rule tells you that when electrons enter orbitals within a sublevel, say a 2p sublevel, they populate those orbitals singly before they double up. So you would not double up these electrons until you have to, until all 3 of those are full. So when you get to something like oxygen, and oxygen has 8 electrons, and its electron configuration is 1s2, 2s2, 2p4. You would write 1s and show the 2 electrons, 2s, show the 2 electrons, and then 2p, you would put them in one at a time and then double them up. So again, if you tried to write the 4 electrons in oxygen's 2p, if you wrote this, you would be incorrect because Hund's rule says they populate 1, 1, 1, then they double up when they have to. And think about it, they both have negative charges. They're gonna wanna spread out before they double up. So let's do something a little bit more complicated. So let's do cobalt's orbital filling diagram. And if I look at cobalt on the periodic table, it has 27 electrons, and its electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. Now you don't have to write out the electron configuration every time you do orbital filling because you're essentially writing it out underneath, showing these superscripts as the arrows going up and down. So you could just go right into the orbital filling, but I'm writing out the electron configuration first. So I show the 2 electrons in the 1s, the 2 electrons in the 2s. I draw 3 lines anytime I have the p orbital in my 2p, and I draw 1, 2, 3, 4, 5, 6. Now some people like to make arrows like this. It's just a little bit quicker not to do both sides of the tip of the arrow, so sometimes I just write them like this. But writing them like this is perfectly fine too. And then I go to my 3s and I show my 2 electrons. I move to my 3p and I show my 6 electrons. I move to my 4s and I show my 2 electrons. And then I move to my 3d. D orbitals have 5 orientations. They can hold a total of 10 electrons, but we only have 7 here. So when you go to the 3D, you want to write 5 lines. And then they fill one at a time, and then they double up. So now I have 7. So these superscripts match the number of arrows. So I have 27 electrons. If you add up the superscripts, you get 27 electrons. And if you add up all the arrows, you also get 27 electrons. And if you were to get to an element that has electrons in f orbitals, so if you had a 4f, you would have to write 7 because there are 7 orientations of f orbitals, and f orbitals can hold a total of 14 electrons. So that's it for orbital filling.